Let's first understand what is the need and purpose of star identification. Now we have been working out the sites to fix up or find the position of the ship. We use various celestial bodies for working out the sites. The sun, the planets, Venus, Mars, Jupiter, and Saturn, the four planets are used for celestial navigation, the moon, and the stars. Now, when we use the stars for site taking, for fixing up our position, one important thing which is involved in the process is the identification of the star. When we go out to take a site and we observe a particular star, we take its altitude, we take its azimuth, and then we come inside to work out that site. Now, for working out the star site, we need to identify the star whose altitude or whose site has been taken. This is required because we need to get the almanac data for that particular star, that is its SHA and declination. It has to be picked up from the almanac, then only the site can be solved. So to obtain this information from the almanac, we need to identify which star is this, which we have used for taking our site. Using a star finder, you can see a star finder on the screen right now. This star finder has a base template. There are two base templates basically, one for the northern hemisphere, other one for the southern hemisphere. And on this base template, we place transparencies. There are different transparent sheets basis different DR latitudes. And once you place this transparency, you align it with the base template using the LHA of Aries. So LHA of Aries is calculated for that particular time when site is taken. And when the LHA Aries is aligned with the base template, you are able to see all the important stars which are there in your view, or which you can observe and use them for site solving. So you will get approximate altitudes and approximate bearings or azimuth of all those stars. So this helps you to identify which is the star which you have used for your site taking. Now, as the technology has grown up, we now have various free applications which are available on our smartphones also. Google Sky Map is one of these applications. You can see these applications on the Play Store, and you can easily use them to identify the stars. So this is what is practically done on board a ship, and this is what is the need and purpose of star identification. Now, when this question comes in our exams related to star identification, we are not given a star finder, nor we have access to our phones. So for examination purpose, we will need to identify the star using the almanac information only. So we are now going to see how to identify a particular star which has been used by the navigator for site taking using the almanac data. This is done using the rational horizon diagram. So we use the rational horizon diagram, or the diagram of the celestial sphere made on the plane of the rational horizon, to solve these type of questions. Now, when we use the rational horizon diagram for identifying a star, the basic concept which is used is that we fill up all the given information to us. whatever information is provided to us in the question, all that information is filled up in the rational horizon diagram. Now, once you fill that up, the rational horizon diagram will give you the PZX triangle. So once this PZX triangle is there and some of its parts are known, PZX triangle is a spherical triangle. So we can apply the spherical trigonometry formula like the cosine formula or the Napier's rule, whichever is applicable in a particular situation. We can apply these formulas, and using them, we are able to easily identify the star. So this is the basic concept which we use in star identification. Now, before we go into the rational horizon diagram and the application of spherical trigonometry, we need to have clarity about some basic concepts which are used in solving these type of questions. These concepts are number one, the concept of stellar magnitude. Now, stellar magnitude basically gives us information about the brightness of a particular star. So this is a system with which we can specify how bright or how dull a particular star is. Along with stellar magnitude, we need to be comfortable with the concept of twilight. The star sights are taken at a particular time in the morning and evening. Sun and moon sight can be taken as convenient. The sun is visible to us during the full day. The sight can be taken at any convenient time. The moon is also available to us sometime during daytime. The sight can be taken at any time. Nighttime, there is a restriction. The horizon may not be visible to us. But about planets and stars, the planet and stars are visible to us during the nighttime. And at that time, the horizon is not visible to us. So we have a particular span of time in the morning and evening which is used for taking a star sight, and that is known as the twilight time. So we have to be familiar with the different types of twilight, and out of them, which is the most suitable time for taking a star sight. The third concept which we need to be comfortable with is the stars information table, which is given in the nautical almanac. So if you go in the nautical almanac, you have the information related to the stars given on the daily pages also. But in the daily page, there are only some selected stars, to be precise, 57 selected stars, whose information or SHA and declination is provided on a daily basis. But there are many more stars in the sky which may be used for sight taking. So all these stars are listed in a separate table in the nautical almanac. And since we are using the 1992 nautical almanac for our exam purpose, in that almanac, we have that star table given at page number 268. So we will just have a look into how does the table look like, what all information does the table provide to us. We also need to be familiar with the concept of time and LHA. LHA is the local R angle of the celestial body, and also with the concept of LIT. LIT is longitude in time, and the SHA. SHA is the sidereal R angle of the star. So we will go into these concepts, understand them, refresh them in our mind, and then proceed ahead with the working out of a star identification problem.
We are happy to present this video on star identification, which besides helping you in attempting the question in your examination may also be very useful on board in case you need to identify a star. We start our discussion by understanding the term that is used to describe the brightness of a celestial body, and that is the apparent magnitude, which is measure of the brightness of a celestial body as observed in night sky from the earth. Why we are interested in the apparent magnitude and not maybe something called as absolute magnitude? Because we are interested in observing the body from the surface of the earth so that it can be used for taking observations. Now, the apparent magnitude of a celestial body depends on its absolute magnitude, which is the measure of its brightness or luminosity, the distance of the celestial body from the earth, and also the transparency of the intervening medium, be it the atmosphere of the earth or be it the transparency of the space. Magnitude scale that we use is reverse logarithmic. That means it's not a linear scale, it's logarithmic. And reverse here means that lower the magnitude, brighter the object. We can calculate how many times a celestial body appears brighter than the other by using a simple relationship. Relative brightness is equal to 2.51 raised to power x, where x is the difference between the magnitudes of the two bodies, relative magnitude number of the two bodies. This means that if the difference between the relative magnitudes of the two bodies is 1, it means their brightness ratio is 1 is to 2.51. Why? Because it will be 2.51 raised to power 1. A magnitude 1 star is 100 times brighter than a magnitude 6 star. Why? If you put difference of 6 and 1, that is 5 in the formula, 2.51 raised to power 5 will be almost 100. Likewise, a star of magnitude 2 is 2.51 times brighter than the star of magnitude 3, and the star of magnitude 2 is 6.31 times brighter than a star of magnitude 4, that will be 2.51 raised to power 2.
So, beta, is this clear? The stellar magnitude relative brightness formula 2.51 raised to power x. Okay, all right. Basically, beta, this stellar magnitude concept was brought in the olden days when we used to look at the stars. When you look at the sky, some of the stars would appear very bright, some would appear like medium brightness, and some stars would be very, very dull, very faint stars. So if the visibility deteriorates a little bit, or if the magnitude is little lesser than that, it will disappear from our view. So in the olden days, they used a very simple method. They said the most bright stars, let us call them number one stars. It is something similar to जब कोई क्लास में फर्स्ट आता है तो हम उसे नंबर वन पोजीशन दे देते हैं. So they said the brightest star which is there in the sky, let's call it number one star. And they kept on giving the numbers to star in that particular fashion. और जो सबसे फेंट वाला स्टार था उन्होंने उसको नंबर दे दिया नंबर 6. So that's how this stellar magnitude scale came into being. Later on, we could connect it to logarithm and we could derive this formula that अगर हमारे पास दो stars available हैं and दोनों का stellar magnitude हमें पता है, we can find out how many times a particular star is brighter than the other by using this formula. So you can just calculate the difference of magnitude of two celestial bodies and put it in the formula 2.51 raised to power x. It will immediately tell you how many times is one body brighter than the other. So is this clear up to here, beta?
Yes.
Yes, sir.
Okay, all right.
The faintest stars visible to the naked eye on a darkest night have an apparent magnitude of about 6 to 6.5, though this varies depending on the person's eyesight, star's altitude, and the atmospheric conditions. The apparent magnitudes of some of the brighter bodies used for celestial navigation are Sun minus 26.7, Moon minus 12.5, Venus minus 4.2, and Sirius minus 1.5, showing that brighter the object, lesser is the apparent magnitude number assigned to it.
Now, beta, you see, when this system was brought in, they named the brightest star as number 1 and the faintest one as number 6. Later on, people said, why not include the sun and moon also in this scale? And the planets also. So, when they included the sun and the moon and the planets, now some of them were brighter than even the brightest of the stars. So, how to include them in the scale? So अभी तक जो हमारा स्केल था, number 6 was a very dull faint star, number 5 brighter than that, 4 brighter than that, number 1 was the most brightest of all. So if we have the sun and moon which is even brighter than number 1, the scale has to go in negative in that case. So that's how the scale went into negative. And that's how you see the sun's magnitude was minus 26.7, moon was minus 12.5, and so on. So that is the reason for this negative scaling.
सर सर वन
हाँ
डाउट
बोलो बेटा.
सर जब मतलब उन लोगों ने सर जब डिसाइड किया था कि जो सबसे ब्राइटेस्ट स्टार होगा उसको वन देंगे, तो सर वो कौन सा स्टार था जो मतलब वन था, क्योंकि सर सीरियस तो सबसे ज्यादा मतलब ब्राइट होता है, तो सीरियस
राइट
को वन
बेटा,
नंबर क्यों नहीं दिया?
राइट. अब बेटा, nobody knows why they didn't do it at that time. Most probably they were not aware that Sirius is a star. Maybe they were thinking that time that this is a planet or something like that.
ओके सर.
Okay, so with their limited knowledge, whichever body they thought was the brightest star was taken as one. Now we can check in the table and we can see which all stars are there having 1.0 magnitude. They must have used one of those stars as their reference. Okay, beta?
यस सर.
Okay.
The measurement of apparent magnitude is called as photometry. What is the suitable time for stellar observations? Obviously, the suitable time shall be when the stars or the planets are visible in the sky, and so is the horizon of the observer. Why? Because the observations have to be made with respect to the observer's horizon. So obviously then, to meet both these conditions, the suitable time shall be a certain period before sunrise in the morning and a certain period after sunset in the evening. And this period is referred to as twilight. During the twilight, the atmosphere is partially illuminated by sun, being neither totally dark or completely lit. However, there are three categories of twilight that are defined by how far is the sun center below the horizon. And these three categories are civil twilight, nautical twilight, and the astronomical twilight. Let us understand a little more about the twilights through this diagram. In this diagram, the observer is at the center of the circle, and this diameter of the circle represents the observer's horizon. The circle here represents the daily apparent path of the sun. We all know that Earth rotates from west to east, and therefore, because of this, the sun appears to be rising on the eastern horizon, moving across from east to west and setting on the western horizon. So in the morning, when the sun center is 18 degrees below the horizon of the observer, that is the beginning of what we call as the astronomical twilight. Now, during this astronomical twilight, obviously, the practically all stars and planets are visible because it's reasonably dark. However, the horizon is not discernible because of the lack of light. And therefore, during this period, astronomical observations or the sights may not be possible because the horizon is not clearly visible. When the sun's center reaches 12 degrees below the horizon, that is the time when nautical twilight starts. Now, during nautical twilight, obviously, the lighting has improved. So therefore, the faint stars may not be visible, but the stars and planets that we use for navigation are all visible during the nautical twilight. And at the same time, because of improved lighting, now the horizon is also visible. Therefore, nautical twilight, as the name suggests, is the suitable period for taking star observations. Now, when the sun center reaches 6 degrees below the horizon, that is the beginning of the civil twilight. During civil twilight, only the bright or very bright stars and planets can be seen because the light has further improved. Horizon is not an issue because that becomes even more clear. So during the civil twilight period, yes, if the stars or planets are visible in the sky, they can be very conveniently used for taking observations. Now,
So, beta, is this clear up to here?
सर
Any doubts?
सर जैसे ही सर मतलब होराइजन के नीचे से जा रहा है वो सन, तो सर 6 डिग्री तक मतलब चलेगी सिविल टॉयलाइट। उसके बाद फिर 6 से 12 में चलेगी नॉटिकल, और 12 से 18 में चलेगा एस्ट्रोनॉमिकल। ऐसा ही है ना सर?
नहीं बेटा, इसमें एक करेक्शन है।
हम्म,
अभी तो हम मॉर्निंग की बात कर रहे हैं, ईस्ट होराइजन की। जब
हम्म,
सन 18 डिग्रीज पे आएगा, सबसे पहले इट विल बी 18 डिग्रीज बिलो द होराइजन, तो
हम्म,
एस्ट्रोनॉमिकल ट्वाइलाइट शुरू हो जाएगी।
हम्म,
ओके। जब सन 12 डिग्रीज बिलो द होराइजन आएगा तो नॉटिकल ट्वाइलाइट शुरू हो जाएगी। और
हम्म,
जब सन 6 डिग्रीज बिलो द होराइजन आएगा तो सिविल
हम्म,
ट्वाइलाइट शुरू हो जाएगी। ये तीनों की तीनों सनराइज तक चलती रहेंगी। All three of them would end at the time of sunrise. इसका
ओ,
मतलब ये है कि ये तीनों आपस में ओवरलैप भी करती हैं। ओके। जो
यस,
एस्ट्रोनॉमिकल ट्वाइलाइट है ये 18 डिग्रीज सन की मोशन को कैप्चर करती है, -18 टू सनराइज। जो नॉटिकल ट्वाइलाइट है ये कैप्चर करती है -12 टू सनराइज। सिविल
हम्म,
ट्वाइलाइट कैप्चर्स इट -6 to sunrise. So all three of them overlap for some period of time.
ओके सर।
Okay. Okay, let's proceed ahead.
now, though each of these twilights have begun at different timings, astronomical when 18 degrees below horizon, nautical when the center of the sun is 12 degrees below horizon, civil when the center of the sun is 6 degrees below horizon, but all the three twilights end when? They all end at visible sunrise. Please mark my words, visible sunrise. Now thereafter the sun is up and it's daylight for the observer. Sun apparently moves across the sky from east to west, and when it reaches the western horizon, it's time for the sun to set. Now, as the sun sets, all the three twilights begin. Civil, nautical, astronomical all begin. Now, when the sun center reaches 6 degrees below the horizon, it is end of civil twilight. When the sun center reaches 12 degrees below the horizon, that's the end of nautical twilight. And when the sun center reaches 18 degrees below the horizon, that is the end of astronomical twilight. And now you have the night or the hours of darkness. Now, which one is more, whether daylight hours are greater than hours of darkness or vice versa, will depend upon the latitude of the observer and the declination of the sun. Let us now.
So this is clear, beta? Understood up to here?
सर ये विजिबल सनराइज क्या बोला सर?
Okay. अभी के लिए बेटा you consider it as sunrise and sunset. Okay. Later on when we go deep, I'll tell you what is the difference between a visible sunrise and the actual sunrise. So अभी के लिए you consider it as sunrise. That's all.
ओके
हाँ, go ahead बेटा.
टॉप पार्ट टच कर जाता है.
You were not clear बेटा. Can you repeat?
सर एक्चुअल तभी होता है ना जब उसका टॉप पार्ट सन का टॉप पार्ट टच कर जाता है होराइजन को.
Right beta, right. The sunrise, exact moment of sunrise is basically, you see in the morning time, let us say the sun has not risen yet. आप कहीं sunrise देखने जाते हो, let us say आप किसी लेक पे या किसी जगह पे sunrise देखने चले गए. So when you look there, और आप अपनी navigational watch पे हो, morning watch में, and you are seeing the sunrise, the instant when you see the topmost portion of the sun just coming out of the horizon, that is known as the visible sunrise. That instant, that time is known as the visible sunrise. And similarly, in the evening, when sunset is about to happen and आप sunset देखते हो, so when the last part of the sun dips into the horizon or below the horizon, that is the visible sunset. So that instant of time is what we call as sunrise and sunset. आपको जो time दिए रहते हैं almanac में, the times which are given, sunrise time and sunset times, or even in newspapers, they all refer to this particular instant.
सर
बोलो बेटा.
सर इसका मतलब यही हो गया ना, सन का जो टॉप पार्ट है वो जब बाहर आ रहा है वही विजिबल सनराइज हो गया, और वही टॉप पार्ट सब नीचे जाएगा वही विजिबल सनसेट हो जाएगा.
हाँ, आप बोल सकते हो ऐसा, पर इसमें एक कैच है. जो सुबह में टॉप पार्ट था वो शाम को बॉटम बन जाता है. ओके, द सेम पार्ट ऑफ द सन विच वाज इन द टॉप इन द मॉर्निंग गोज टू द बॉटम इन द इवनिंग. हाँ, सो इसका ध्यान रखना है आपने.
सर अपर लिंग बोल सकते हैं सर, जो ऊपर रहेगा तो अपर लिंग.
Okay, yeah, you can say the upper limb, yes, because morning and evening, both the cases, it is the upper limb. When the upper limb goes below the horizon or comes out of the horizon, that is the visible sunrise or visible sunset.
बट सर ये एक्चुअली तो सनराइज सर हो चुका रहता है उस टाइम बिकॉज ऑफ द रिफ्रैक्शन ऑल द अदर थिंग्स.
नहीं, एक्चुअली सनराइज हुआ नहीं होता है उस टाइम पे.
हाँ
Okay.
सर, मतलब एक्चुअली हुआ नहीं रहता है बिकॉज ऑफ द
Yeah.
रिफ्रैक्शन ऑल वी कैन सी द सन एक्चुअली.
Right. Actually, the sun is below the horizon at that time, but we are able to see it a little early in the morning. That's because of the refraction of the atmosphere. Okay. So, any more doubts, beta?
नो सर, थैंक यू सर.
सर इसमें एक चीज सर, जो नॉटिकल ट्वाइलाइट है दैट इज बेस्ट फॉर टेकिंग साइट्स, राइट?
Not nautical twilight, I'll tell you. The best period for taking sight in the morning is commencement of the nautical twilight, which happens when the sun is 12 degrees below the horizon, to commencement of the civil twilight, that is when the sun is 6 degrees below the horizon. This blue shaded portion is the most suitable time for taking sight, because when you come in the dark gray portion, in the dark gray portion the sun is more than 12 degrees below, and the light is very faint and dim and you cannot see the horizon. And when you come in the light gray portion, In the light gray portion, the light is so bright that the celestial bodies start to disappear. So the most suitable time is in the morning, commencement of the nautical twilight to commencement of the civil twilight. And if you talk about it in the evening, it is ending of the civil twilight to ending of the nautical twilight. That is the most suitable period.
सर लेकिन पता कैसे पड़ेगा सर कि
Okay, sir.
अभी ये सिविल में चल रहा है कि नॉटिकल में चल रहा है, अपन को तो दिखाई नहीं पड़ेगा सर नीचे।
उसका टाइम
ये भी बात सही है। अब हॉराइजन के नीचे तो सन दिखाई नहीं देगा, तो पता कैसे चलेगा? अब ये जो चीज़ है ये एल्मनैक में हमें उन्होंने दे रखी है। सो हम एल्मनैक में जाके इन इंस्टेंट का टाइम निकाल सकते हैं। व्हाट इज द टाइम व्हेन नॉटिकल ट्वाइलाइट इज स्टार्टिंग टुडे? व्हाट इज द टाइम व्हेन सिविल ट्वाइलाइट इज स्टार्टिंग? व्हाट इज द टाइम व्हेन दे आर एंडिंग? दीज आर गिवन टू अस इन द एल्मनैक।
यस सर, गिवन सर, नॉटिकल एंड सिविल।
राइट। एस्ट्रोनॉमिकल ट्वाइलाइट का टाइम हमें एल्मनैक में नहीं दिया होता because that is not required. It is basically used by people who are observing the sky using instruments, using telescopes and all. So we don't have this in the nautical almanac. The astronomical twilight time, nautical and civil are both mentioned. Okay, beta.
Okay,
All right.
yes.